Hi, welcome back to another past paper walkthrough. Today we're doing Mechanics 1 for OCR and MEI. So without further ado, let's jump right into Section A. Section A, Question 1. Show that P is 14 and therefore find Q and give your answer to 368. Okay, so in order to find P and Q, we need to know that this is in equilibrium, and therefore we can do some calculations on the horizontal and vertical components. So the sum of the vertical components will be equal to P Newton upwards. So let's denote upward as positive, downward as negative, plus the negative 12 Newton because it's going downwards, sine 30 if you did the method of resolving. So that is negative 12 sine of 30 degrees. And you still got another force with a vertical component to it. So that is 8 root 2 newtons in 45 degrees. So that would be another subtract 8 root 2 sine of this time 45 degrees. So all you need to do now is to plug them into your calculator, which I need to go get. And the sum of the vertical factors must equal to 0 for an equilibrium. So 0 is equal to P subtract by 12 sine 30 subtract by 8 root 2 sine of 45. And by rearranging we can find P. So P is 12 sine of 30. Make sure you have your angle unit set as degrees. So 12 sine 30 add 8 root 2 sine of 45 gives you exactly 14. And so that is what you need to prove or show. Now find Q. So to find Q, do exactly the same thing for the horizontal factors, or horizontal components rather. This time, because we want to find Q, let's take left as positive and right as negative. So the only forces with a horizontal component is Q, 8 root 2, and 12, respectively. And this time, in order to find the horizontal components, we again add them all up to 0. So Q on the left plus 8 root 2 cos 45 and because 12 Newton is going away or going to the right, and therefore we take away 12 cos of 30 degrees. So again, you can rearrange everything to get your Q, and this time it would be 12 cos 30 subtract by 8 root 2 cos of 45, which gives you 2.3923 or in 3SF 2.39 newtons. And that is question 1 done. Okay, so for question 2 we have a very typical 3-mass body kind of on a table diagram or question. Part 1, draw 3 separate diagrams showing all the forces acting on each blocks. And part 2, calculate the acceleration of the entire system and also the tension on both strings. Okay, so let's start with the free body diagram. Let's go with the 2 kilogram first. So for a 2 kilogram mass, we have a force going upwards and a force going downwards. The downward force is its weight, so that is mg or 2g. And going up is a tension, let's call it T1 for now. For the 6 kilogram mass, we have again a block. There's some force going to the right and some force going to the left. And also there are mg going down and mg going up and r, the normal reaction force, going up, and therefore this 6 kilogram mass doesn't just fall straight through the table. So we have r, we have the weight, and we have, because this is a string, it retains its force, and therefore tension is uniform in the string, and therefore there is a tension T1 pulling on the left. And for the right, there's another string, and so let us call it T2. Now move on to the last block, which is 9 kilograms. And once again we have a block of notated by a square, and similar to the first block, 2 kilograms, we have a force downwards, which is the weight, which again is 9g mg, and going upwards we have a tension T2, because we have stated it is T2 and it's the same string on a smooth pulley, and therefore it have to be T2 again. So that is part 1 done. For part 2, it is a little bit more difficult, but it's still doable. So because this entire system is not in equilibrium, and we can say that it accelerates towards some direction, and by just looking at it, you can probably guess which way this whole system is going to fall. It's going to fall towards the heavier side, and therefore let's first take a look at the acceleration of this 9 kilogram block. So say the acceleration of the 9 kilogram block is going downwards, the acceleration of the 6 kilogram block is going to the right, and the acceleration of the 2 kilogram block is going up. The force on the 9 kilogram mass is respectively T2, as we stated, going upwards, and mg, 9g that is, going downwards. And because it's accelerating downwards, we use Newton's second law, which is F equals ma. So the resultant force is 9g subtract by T2, which equals to ma, mass times acceleration. So mass is 9, acceleration is just a, because we want to find a. And the entire system, because everything is in tension, they accelerate at the same rate. So we have done one side of the equation, and obviously we do not have enough information to solve this entire thing. So let's go and find another block to calculate. Let's take this 2 kilogram block, because the 6 kilogram block won't give us any information that we can use to deduce the acceleration. Well, actually, you do need it. My bad. Let's go for the 6 kilogram then. So this time the weight doesn't come into the equation, because the vertical component, as we know, is constant, because that block doesn't fall through the table, nor does it suddenly spontaneously fly off into the air. So there are only horizontal components to this thing, and apparently the one on the right is larger than the one on the left, and therefore we can deduce that T2 subtract by T1 is equal to 6a, because, well, ma. and resulting force is T2 subtract by T1. Now, same thing for the 2 kilogram mass as the 9 kilogram mass. So we have again a force a resultant force equals to mass times acceleration, but this time the larger force is the tension. So we have a T1 subtract by 2G equals to 2A. So the main difference of this is the direction of travel corresponds to whether you have the weight subtract by the tension or do you have the tension subtract by the weight. Now, all we need to do is solve these equations, and for now let's see, T1 is equal to 2A plus 2G, and therefore 6A is equal to T2 subtract by 2A subtracted by 2G. And 6A and 2A can come together to 8A plus 2G equals to T2. So we have an expression for T2 already, which is this, and therefore if we just plug that in, 9G take away 2G take away 8A is equal to 9A. And by just rearranging everything, we get 17A equals to 7G. And therefore A is 7G over 17, which, when you plug it into the calculator and use G as 9.8 as all mechanics paper asks for, and it's written in the front page of the exam as well. It's 4.04 meters per second squared, and this is 3 significant figures. So that is the acceleration of the entire system, and we now need to find respectively T1 and T2. Given that we have the acceleration, let's just use them. So T1 is 2A plus 2G from this side of the equation. So we can deduce that T1 is whatever we got times 2 plus 2 times 9.8, because 2G is 2 times 9.8, gives you 27.7 newtons. That is 0.670588, by the way. For T2, we can use this 2G plus 8A. T2 is, let me have a look, times 8 plus 2 times 9.8 give me 51.9, that is 0.88235 newtons. And so we have T1 and T2, and that is question 2 done. Question 3, the map of a large area of open land is marked in 1 kilometer squares, and a point near the middle is defined to be the origin. And 1, 0 and 0, 1 are direction east and north, so it's practically just x and y coordinates, and we're dealing with factors here. At time t, position factors are given by this and that, so prove that the two hikers meet and give the coordinate of the point they meet, and also compare the speeds of the two hikers. For this one, let's find using the horizontal coordinates, which I will just refer to x, and the vertical as y, because it saves me brain power to just say x and y. So let's find where they meet. To meet, they will have to have the same x and same y, and therefore let's find the time at which x is, well, the two x's are equal. So when at time t, x of Ra is equal to x of Rk, and therefore the x is the top numbers, and therefore it's for Ra it is minus 2 plus 8t, and that would have to equal to the x of Rk, which is 70. And by just rearranging, you get a nice t equals 2. And now we just need to put in t equals 2 onto the y's to find if they are equal. If they're equal, they meet. So for the y of Ra, it's equal to 0 plus t, which is 2, gives you a 2. And for Rk, it is 10 subtracted by 4 lots of 2's, which is 10 minus 8, 2 again, and therefore they are equal. So right now you have the y coordinate 2. I just write y, but it really isn't y because it's north, but I'll just for good reasons. Now we need to find the exact coordinate, which means that we need to substitute that 2 t equals 2 into the x coordinate. So the easiest one will be 7t, because we just multiply 2 by 7 gives us 14, and therefore the coordinate is 14, 2, and give it in vertical column factor because the question is structured that way, and it will prevent any confusion. To find velocity this time, we need to differentiate Ra and Rk, which is relatively simple if you just break it down as y and x form, but it's only anything to do with t, because these constants will be cancelled. So phi of a is 8, 1, and phi of k is, if you differentiate that, you get 7, 10 goes away, and you are left with minus 4. So these are the two velocity. Now compare their speed means that I need to ignore all directions. So let's find the magnitude of these factors. For this, it's 8 squared plus 1 squared square root, which gives me 65 root. And for this one is 49 plus 16, which gives me 65 again. So compare them, they have the same speed. And that is it for this question. Question 4, it's about a car accelerating. So these wordings are quite horrible because most of the time these just they are designed to confuse you. So when the car passes A, its speed is 12 meters per second in direction AB, so we're still on A. It then accelerates uniformly from A until it reaches B. So it's constantly accelerating through from A to M to B, instead of, say, constant speed at A to M, then accelerates till 31 at B. It's not that. It's just like literally uniform. So don't get confused. The entire length or displacement of A and B is 215 meters. So we need to find the acceleration, the time it took from A to B, and the time it took from A to M. Then using these two things to explain, why the speed of the car from A to M took more than half of the time from A to B, given that M is the midpoint of AB. Alright, so let's find the acceleration. So because the acceleration is constant, we can say that we can use the Seurat equations. So we have given to us as the displacement, we have the u, the initial velocity, and the v, the final velocity, and we want to find a. So what equation includes all these? Off the top of my mind, that is v squared equals to u squared plus 2as. So let's use this equation. So v squared, which is 31 squared, is 12 squared, 144, plus 2 times 215a. And if we plug these numbers into the calculator, so you get 817 equals to 430a, and therefore a is 19/10 or 1.9 meter per second squared. So once we've done this, we can find AB. So the time taken to travel from A to B can be found. Actually, no, you have to use A, I guess. So let's find AB. We know AB we have S, and that's just 215. We have U, and we have the acceleration A, and we want to find T. The equation that have these are, we have also V, so we can either use S equals to UT plus half AT squared, or S equals to VT subtract by half AT squared. And or we can also use V equals U plus AT, and that would be the best one to use because we know the acceleration this time. We can find T much easier rather than to solve a quadratic formula. So let's see, V is 31, U is 12 plus 1.9 T. And if we do 31 take 12, we get 19, and divide that by 1.9, you get 10. So T is 10 seconds. So that is the time taken to go from A to B, so that is part 2 done. And finally, we need to find the time taken from A to M. So this time, we cannot use this easy equation. We have to actually use one of these horrible ones. So let's, I guess, do that. Is there a way around it? I do not think so, certainly. Or we can find, well, let's do the one-step process. It's gonna be a bit easier, I think. So let's use S equals UT plus half AT squared, because that's the most familiar one. AM is half of 215, so that will give me 107.5 equals to UT 12T plus half of 1.9, which is 0.95 T squared. And let's rearrange that so that we get 0.95 T squared at 12T subtract by 107.5 equals 0. So quadratic formula, this is t equals to minus 12 plus or minus the root of b squared minus 4ac, and because c is negative, you add 4 times 0.95 times 107.5 gives you 408.5. Divide that by 2a, which is 1.9. And t have to be positive, and therefore this cannot be a negative, and therefore this will have to be positive. So which that 408.5 plus 144 and square root that gives me something to the degree of 23.5 minus 12 plus that divided by 1.9, that would be our time, and that is the equivalent of 6.055 seconds. And so that is part 3 done. So part 4, it's a 1 marker. You need to explain why does it take more than 5 seconds, half of 10, to get from A to M. The reason is, I'm not going to write it down, but you can just listen to me. The reason is because when you travel on uniform acceleration, you will travel faster and faster along the way, and therefore you cover more distances at the later stage of your traveling, because your speed is faster at the later stage, and therefore you spend more time traveling slower in the front half compared to you spend less time traveling faster at the later stage. And that's why there is this 1.06 second discrepancy. Question 5. A golf ball is hit at an angle of 60 degrees horizontal from a point O, and initial speed is 20 meters per second. And when air resistance is neglected, the motion is described as x and y meters in time t. And you need to write down equations for x and y in terms of t, so those are SUVATs. And part 2 show that the equation of the trajectory is this horrible thing, which is just simultaneous equation. Part 3, find the range of the golf ball. So basically find when y is 0, how far can x get. And finally part 4, a bird is hovering at position 20 and 16. And we need to find if the ball passes above, below, or hits it. So that's a bit violent. So for part 1, let's find the x and y expressions. So to find x, it's the horizontal distance. It doesn't get affected by air resistance, and therefore it has a constant velocity. So by just doing cosine of 60, you get 20 cos of 60 equals to x. And x is the position, and therefore you need to also multiply by the time that it took to travel, so you multiply that by t. And 20 cosine 60 is just 10. Cos 60 is a half, so we get x equals 10t. So that's relatively simple. For the vertical component, however, you need to consider the constant acceleration from the gravitational force, and that is just acceleration equals g. So the initial, well, let's use SUVAT for this purpose. So we want to find s for vertical, and we have u, and we need to find the vertical component of that 20 in order to get u, but we can find it. We can use things in terms of t, because that's what we have been asked to do, and we have the acceleration g, or a, in the downward direction. Since s is upward, g is downward, we take g as negative. So for this, if this is a, we can use s equals ut plus half at squared again. So we have s, or let's call it y this time, because that's what we want to find. Y is equal to u, which is 20 sine of 60, times t, ut, plus half of at, and a is minus g, t squared, and so we get 20 sine 60 this time, and this will not be a good number. It's 10√3, and I guess that is in some sense nice, but not really. Subtract by g is 9.8, so that is 4.9 minus 4.9 t squared. So we have x and y in terms of t. For part 2, we need to substitute in x in order to find y in terms of x. So let's do that. T is equal to x over 10. And therefore, we can substitute x over 10 into the y equation. So y is equals to 10√3 x over 10 minus 4.9 x over 10 squared. And if you do that, the 10s can cross out, so you're left with √3x subtracted by 4.9 over 100 x squared, and that is just √3x subtracted by 0.049 x squared. So that is relatively simple. Part 3, we need to find the range, and the range is when the ball hits the ground again. So y is 0 in this case, and we need to solve for x. So this is 0 equals √3x minus 0.049 x squared. And this one we can factorize out the x to get √3 take 0.049 x equals to 0. So x is 0 when y is 0. That is because that's when we start, where we start the ball. And the final horizontal distance will be denoted by this x in the bracket. So let's find that. So x, if you rearrange that bracket, equals to 0, you get that x is √3 divided by 0.049, and if you put that into a calculator, you get 35.3479756. I'll just end it with 6, and that is in 3 significant figures 35.3 meters, or whatever unit they used. So that is part 3 done. Let's move on to part 4. So in order to find if the ball hits the bird or passes above or below, we need to find the y coordinate of the ball when it is at the same x coordinate of the bird. So let's substitute in x. So √3 times 20 subtracted by 0.049 20 squared, which you can just use a calculator to calculate your numbers. Gives you a value of y equals 15.0 meter exactly. So it just narrowly missed the bird by 1 meter. And of course, do put down it passes below the bird. So this concludes for the section A of this M1 paper. Overall, it is a very typical paper, not very hard at all. And to be honest, nothing more to say about. But actually, one thing that I want to show you guys, which will help you tremendously when doing these resolving questions. Let's get on with this tip. So the tip I want to show is the fastest way, literally, to resolve any forces. You do not need to care about what triangle to draw at all. You just need to know that this method works. It does save you a whole ton of time. So when you're thinking about resolving, you are always having a force in between two angles. So one of the angle that you know and one angle that you do not know. So you either go away from the angle or you go towards the angle. So if you say go towards the angle, imagine this theta is an object in the middle, a rubber or a spring. So if you crush it, crush the angle, get you cosine of theta. And if you go the other way, you stretch the angle, which gives you sine of theta. So notice that if you remember this well, then you will literally just look at it and say that, oh, this is just sine, oh, this is just cos. Always, it works every single time. Make sure to try this out. It's really, really good to save time. But if you cannot understand this at all, then just ignore this tip and do the triangle method. It's the safe bet, always. So yeah, this is it for this video. I hope you really enjoyed, and if that tip saved you some time, then make sure to leave a comment in the section below to tell me that it helped you or something like that. And I will see you next time with section B.